Okay. All right. In case I don't reply to your chat, that would mean I can't see it. So then you'll text me. Okay. All right. Let's start. This is February March 2020, paper 5-2. Okay. So 40 members of a club include Ranif and Said. All 40 members will travel to a concert. 35 members will travel in a coach, and other 5 will travel in a car. Rauf will be in the coach, and Said will be in the car. In how many different ways can the members who will travel in the coach be chosen? Okay, so all 40 members will travel to a concert, 35 members will travel in coach, and one of these is Rauf. So I'm going to write 1C1 for Rauf, and then there are 35 more members traveling in the coach. That means we'll write something C34 because one is Rauf and then there are 34 more left. Now, what do we write here? How many are left after we take out Rauf and after we take out Said as well? Because Said cannot sit in the coach. So that will be 40 minus 2, that would be 38. So we write 38 here. Okay. And in how many ways can the members who will travel in the coach be chosen? So it'll just be 38C 34. That would be the answer. So 73815. That is question number 1. Let's take a look at the next question. An ordinary faced fair die is thrown repeatedly until a 1 or a 6 is obtained. This is showing that it's a question on geometric distribution. Okay, find the probability that it takes at least 3 throws but no more than 5 throws to obtain a 1 or a 6. Okay, so at least 3 throws and not more than 5 throws. That means probability that you get a 1 or a 6 on the third throw, or probability that you get a 1 or a 6 on the fourth throw, or probability that you get a 1 or the 6 on the 1 or 6 on the fifth throw for the first time. You have to add these probability. Probability 3 plus probability 4 plus probability 5. Now, geometric distribution formula is for P3, it's going to be Q square P. Failure the first 2 times, then a success, plus failure the first 3 times, then a success, plus failures the first 4 times, then a success. Now, what's the probability of success? It's getting a 1 or a 6, that's 2 by 6. Probability of success is 2 by 6 or 1 by 3. So probability of failure will then be 2 by 3. Substitute these values in the formula and then find the answer. We can also take P common just to make our working a little less hectic. And I'm writing Q squared, so 2 by 3 squared plus 2 by 3 cubed plus 2 by 3 power 4. Okay, times 1 by 3, which gives us 0.313. And the fraction would be 76 over 243. Okay. Part B. On another occasion, this die is thrown 3 times. The random variable x is the number of times that a 1 or a 6 is obtained. So that means now this is a question on geometric distribution. Draw up the probability distribution table for x. Okay, so when the dice is thrown 3 times, you might not get a 1 or a 0. So I'm going to write x, then probability x equals x here. So we get a 1 or a 6 0 times, or we get a 1 or a 6 1 time, 2 times, and at max 3 times because there are only 3 throws. Okay, now we'll use binomial distribution formula to find this probability. Probability x equals 0 would be the total 3 throws, 3C0. Probability of success was 1/3. There's no success, power 0. Probability of failure gets a power of 3, which gives 8 over 27. So we get an 8 over 27 here. Then we have probability x equals 1, which will be 3C1. Success happens 1 times, failure happens twice, which gives us 12 by 27. Then we have probability x is equals to 2, that we have 2 successes in these 3 attempts. So 1/3 power 2, 2/3 power 1, which is 6 by 27. And for the last one, you can simply do 1 minus all the other answers, sum of all the other answers, or probability x equals to 3 means 3C3. All 3 are successes and there's no failure, which gives us 1 by 27. So this is the probability distribution table. I don't understand your question, Ahmed. Do we need to define? And no, you don't need to define x first. You can just start. X has been defined in the question. आपको कोई statement नहीं लिखनी होती. Okay. Second part, which is find the expected value. Okay, that has a very simple formula. Just multiply these together and start adding them. So 0 times 8 by 27 plus 1 times 12 by 27 plus 2 times 6 by 27 plus 3 times 1 by 27. Which is equals to 1. Okay. Okay, moving on to the next question. Give me a second. Okay, question 3. The weights of apples of a certain variety are normally distributed with mean 82 grams. 22% of these apples have a weight greater than 87 grams. So probability x is greater than 87 is 22%, 0.22. Actually, in normal distribution, we always have to convert this into z is less than something. So I'm going to rewrite this as probability x is less than 87 will then be 100 minus 22, which is 78%. So I'm rewriting it as this. Probability x is less than 87 is 0.78. Okay, now we'll change it into z by subtracting the mean and dividing the standard deviation. So probability z is less than 87 minus mean divided by standard deviation equals 0.78. Probability z is less than 5 divided by standard deviation equals 0.78. Okay, now we're given the probability. We have to find this z score from the probability. So we're going to go to the table and find which z score gives the probability of 0.78. Okay, here's the table. Where is 0.78? अच्छा जी, यहाँ पे we have 0.7794, and if we add 6 to the very last number, we'll get exactly 0.78. So this is 0.772. So 0.772 is the z-score that gives a probability of 0.78. So 0.772. So 5 over sigma is 0.772. Find sigma first, preferably unrounded, 0.476683. Now round it off, 6.48. Okay, now let's take a look at part B. Find the probability that the weight of a randomly chosen apple of this variety differs from the mean weight by less than 4 grams. Okay, this means that the weight needs to be either 4 kg above the mean, or sorry, 4 grams above the mean or 4 grams below the mean. So what was the weight? The mean was originally 82. So we go 84 above 82 and 4 below 82. So 82 plus 4 would be 86, minus 4 would be 78. So this is the probability they're asking you to find. That it needs to lie between 86 and 78. Okay, now to change it into z, we're going to subtract mean, divide by standard deviation. Mean is 82 and standard deviation is 6.476683. Preferably write a longer answer. And here also 86 minus 82, the mean divided by standard deviation. Which gives us minus 0.618 less than z less than 0.618. Remember, for z-score, we only need to go till 3 decimal places. Okay. Now, this means you have to find the probability for a z-score of 0.618. Let me write the formula. If you have negative a, z, and a, the formula is you double phi a and then you subtract 1 from it. So we'll double phi 0.618 and subtract 1 from it. Okay, now let's find the probability for the z-score of 0.618. Okay, so this is 0.6, this is 1, so that's 0.27291, and we also have to add what's under 826 in the end. So 0.7291 plus add 26 to the last two numbers. This is what I'm getting, 0.7317. That's the relevant probability. 0.7317. So we do 2 times 0.7317 minus 1, which gives us 0.463 as the final answer. Okay, next question. Okay. Richard has 3 blue candles, 2 red candles, and 6 green candles. The candles are identical apart from their color. He arranges the 7 candles in a line. Sorry, he arranges the 11 candles in a line. Find the number of different arrangements of the 11 candles if the red candles are at each end. Okay, so there are only 2 red candles, so one here and one here, and in between we'll have 9 other candles. Okay, so let's address this red first. We have 2 spots for 2 red candles, so 2 factorial times in between we have 9 other candles in any order, so 9 factorial, and we divide by the number of repetitions. There are 2 red identical candles, 3 blue identical candles, 6 green identical candles. So we can just cancel 2 factorial and 2 factorial. Even if you don't write this 2 factorial and 2 factorial, your working would be accepted. Answer is 84. Part B. Find the number of different arrangements of the 11 candles if all the blue candles are together and the red candles are not together. Acha, one way of doing this is we can combine the blue candles. Now this becomes one group. This is now a group of one because these cannot be separated. So हमने इसका group बना लिया. Okay. अब the red candles cannot be together, तो फिलहाल red को side पे कर देते हैं दोनों red candles को. And then we have 6 green candles. Let's write that down. 1, 2, 3, 4, 5, 6. Okay, so this would be 3 factorial because there are actually three candles in this group. So 3 factorial times. Now we're going to write the arrangements for this is 1, 2, 3, 4, 5, 6, and this will be the seventh candle. Okay, so 7 factorial times. Now bring in the two red candles. Since the two red candles cannot be together, one can be either placed here towards the left of the three blue candles, one, two places, three places, four places, five places, six, seven, eight. So there are eight available places for these two candles to be placed. So 8p2. And now divide this with all the repetitions we have in the question. We have two red candles, three blue candles, six green candles. So 3 factorial and 3 factorial just gets cancelled, and the rest gives us 196. Okay, there's another way of doing this question as well, which is we do um, total with blue together, क्योंकि blue ने तो इकट्ठा होना ही है. So we find the total arrangements minus uh, the red candles are also together. Put them together and then subtract the result. So total with blue are also together and red are also together. Okay, so let's only look at the case where only the blue candles are together. So we'll have blue, 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 that forms a group of one, and then apart from that we have 9 other candles, so that this will be 3 factorial and then times 9 plus 1, 10 factorial, divided by the number of repetitions. Sorry, ये 10 नहीं था, I made a mistake. 3 candles हटा दी तो we're left with 8. So 3 blue candles and 8 other candles, so that will be 9 factorial. So 3 factorial for the 3 blues times 9 factorial divided by all the repetitions that we have, which is 2, 3 and 6. ये total हो गया. Which is 256. Now we put blue together, the 3 blues are together, and the 2 reds are together as well. And then we have 6 left. Okay, so 6, 7, 8, we have 8 factorial first by grouping these, by arranging these. So 8 factorial, then 3 from the blue group, 2 from the red group, divided by all the repetitions in this questions, 3, 2 and 6. Which gives us 56. So now we do 256 minus 56. नहीं, एक वैल्यू गलत हो गई. Let me check again. 8 factorial by 6 factorial gives 56, and the other one gives 9 factorial divided by 2 factorial and 6 factorial. This is 252, sorry. So 252 minus 56, which gives us 196. Okay, so we get the same answer no matter which method we use. Okay, moving on. In Greenton, 70% of the adults own a car. Random sample of 8 adults from Greenton is chosen. Find the probability that number of adults in this sample who own a car is less than 6. This is binomial distribution. We have to find the probability that the number of adults in the sample who own a car are less than 6. Okay, so that means we can find 1 minus probability x is equals to 6 minus x is equals to 7 minus probability x is equals to 8. So 1 minus, then we have 8 in total, so 8c6. Probability of success is 70%, so 0.7. Power 6, and failure would be 0.3, and the power would be difference of these two, which is 2. Then minus 8c7, 0.7 power 7, 0.3 power 1. Then minus 8c8, probability of success power 8, probability of failure power 0. Enter this in the calculator, you'll get 0.448 after rounding. Okay, part B. A random sample of 120 adults from Greenton is now chosen. Use an approximation to find the probability that more than 75% of them own a car. इसका मतलब है we have to change binomial distribution to normal. Whenever they say use an approximation, that means it's a question on binomial to normal. Okay, so in this question, we take upper bound or lower bound. It says find the probability that more than 75 of them own a car. More than 75 means we'll take the upper bound, 75.5. So I'm rewriting this as Z greater than 75.5. ये हमने continuity correction apply कर दी. इसमें से हम mean subtract करेंगे, standard deviation divide करेंगे. Mean कैसे आएगा? We'll use the binomial distribution formula to find mean, which is n times p. N is given in this question 120. P was also given in the question in the previous part, which is 0.7. Okay, so that gives us 84. So mean is 84, we subtract mean, and now we divide the standard deviation. Standard deviation formula is square root of NPQ. Again, this is the formula for standard deviation of binomial distribution. So 120 into 0.7 into 0.3 square rooted, which gives us 5.01996. So divided by 5.01996, which gives us probability Z is greater than negative 1.6932. Okay. Now we know this rule in normal distribution that if we have probability Z is greater than a negative number, that is the same as probability Z is less than that positive number. So we're going to rewrite this as probability Z is less than 1.6932. Okay. Remember, we only need till 3 decimal places for the Z score. So probability Z is less than 1.693. Okay. So let's find the probability corresponding to the z-score of 1.693. So there's 1.6, 9 is here. So this is the probability. And then we add, last number is 3, so that is also 3. So we add 3 in the end. So 0.9545 and add 3, so we'll get 8. So we're getting 0.9548. So this is 0.9548, but in the marking scheme, they round this off to 3 significant figures because all these probabilities are actually estimated probabilities. ये actually 4 decimal places पे ख़त्म नहीं हो रही होती. These are all estimates. So since this is not an exact answer, it's an estimated answer, or it's not a short decimal answer. So marking scheme में इसलिए इसको further round off किया होता है. I think it should. मैं एक second marking scheme खोल के देखते हैं. What question is this? 5B. Yes, so see it says allow the values in between these. So हो जाएगा. They will accept. But you'll notice always कि ना normal distribution में उन्होंने probabilities को 3 significant figures में finally लिखा होता है. And the reason is कि खाली ये 4 decimal places आंसर नहीं होता, इसके बाद और वैल्यूज भी होती हैं, बट यहाँ पे एस्टिमेट करके राउंड ऑफ करके लिखा होता है. दैट्स व्हाई दिस इज नॉट एन एग्जैक्ट आंसर. दैट्स व्हाई इट कैन बी राउंडेड ऑफ टू 3 सिग्निफिकेंट फिगर. ठीक है, बट इवन इफ यू डोंट, अकॉर्डिंग टू द मार्किंग स्कीम इट्स फाइन. ओके, चलें जी, नेक्स्ट क्वेश्चन. Okay. Box A contains 7 red balls and 1 blue ball. तो यहाँ पे अगर हम लिख लें बॉक्स ए में we'll have 7/8 for red and 1/8 for blue. Box B contains 9 red and 5 blue balls. A ball is chosen at random from box A and placed in box B. A ball is then chosen at random from box B. The tree diagram below shows the possibilities of the colors of the balls chosen. Complete the tree diagram. अच्छा, so अब अगर red आया है फर्स्ट बॉल में, तो एक एक्स्ट्रा रेड बॉल चली गई बॉक्स बी में, तो यहाँ पे 10 रेड बॉल्स हो गए. सो आई एम राइटिंग 10 अपॉन, और टोटल में भी ब्लू के टोटल में भी 1 ऐड हो गया, तो यहाँ पे टोटल हो गया 15. So 10/15. And then you can just subtract this from 1 and write 5/15 here. So now, if you get a blue ball in box A, तो एक एडिशनल ब्लू बॉल आ जाएगी बॉक्स बी में, तो हमारे पास आ जाएगा 6/15. फिर इसको 1 से अगर हम माइनस करें तो हमारे पास आ जाएगा 9/15. So that's how we fill the tree diagram.
मिस मरियम, आपके पास सिर्फ, सॉरी टू इंटरप्ट यू, सिर्फ कितने लोग अभी तक हैं? 3 और बच्चे?
बस 3 है मैम जी इस वक्त.
Ma'am, kindly share the list of those who are not attending the class so that we can call their parents.
ठीक है मैम, I'll do that. Okay. Part B. Find the probability that the two balls chosen are not the same color. इधर ही वर्किंग कर लेते हैं. Okay, so for part B, the two balls chosen should not be the same color, so we can get red and then blue, this one, or blue and then red, this one. So I'm going to write 7 by 8 times 5 by 15 plus 1 by 8 times 9 by 15. Which gives us 11 by 13 there. Okay. Part C. Find the probability that the ball chosen from box A is blue, given that the ball chosen from box B is blue. Okay. So probability ball chosen from box A is blue. So let me write A and blue. Given that ball chosen from box B is also blue. Okay, so we're using the conditional probability formula. In the numerator, we will multiply these probability that we get a blue ball from box A and a blue ball from box B, divided by probability that we get a blue ball from box B. Okay, so A में भी blue आना चाहिए और B में भी blue आना चाहिए. So that's this. So numerator में इनका product लिखेंगे 1 by 8 into 6 by 15. So 1 by 8 into 6 by 15 in the numerator, and denominator में box B में blue आना चाहिए. So एक ये केस होगा कि पहले में red और फिर B में blue, या फिर ये केस होगा कि first में भी blue और फिर B में भी blue. So we're going to add these products. 7 by 8 times 5 by 15 plus 1 by 8 times 6 by 15. Which gives us 6 by 41. ठीक है, चलें जी, last question. Okay. Okay. So last question is, Helen measures the length of 150 fish of a certain species in a large pond. These lengths, correct to the nearest centimeters, are summarized in the following table. अच्छा, टेबल को तो देख के पहला ही मसला नज़र आ गया कि इसमें पहले कॉन्टिन्यूटी करेक्शन करनी है. 9 और 10 के बीच में गैप है, 14 और 15 के बीच में गैप है. हमें पहले कॉन्टिन्यूटी करेक्शन करनी पड़ेगी, फिर कम्युलेटिव फ्रीक्वेंसी हम ड्रॉ करेंगे. ठीक है, यू कैन नॉट just directly start plotting the cumulative frequency. ठीक है, so let me draw the table for cumulative frequency. पहले तो हम लिख लेंगे लेंथ 0 और उसकी फ्रीक्वेंसी भी 0 है. ठीक है, यहाँ पे फ्रीक्वेंसी है और यहाँ पे लेंथ है. नेक्स्ट इज हम 9 नहीं लिखेंगे, हम 9 को 0.5 आगे करेंगे. सो 9.5 आ गया इधर, एंड द cumulative frequency is 15. अच्छा, फिर 14 नहीं लिखेंगे, हम लिखेंगे 14.5 और cumulative frequency के लिए इन दोनों को ऐड कर लिया और हमारे पास बन जाएगा 63. Next length would be 19.5 And cumulative frequency would be the sum of these three, which is 129. And then the length will be 30.5 and the cumulative frequency will be 150. This is the correct cumulative frequency table after applying continuity correction. उसके बगैर अगर डायरेक्टली बना दिया ना तो 0 मार्क्स मिलेंगे इस क्वेश्चन में. Okay. Now what do? We first label our x-axis and y-axis very properly क्योंकि वो भी नहीं करेंगे तो 1 मार्क काट लेते हैं ये. Okay. So on the x-axis I'm writing lengths with the unit in centimeters. So lengths in centimeters. Unit लिखना भी ज़रूरी होता है. और y-axis पे we can just write cumulative frequency. ये लेबलिंग नहीं होगी ना तो 1 मार्क कट जाएगा. ये देखो B1 दे रहे हैं लेबल्स करेक्ट. लेबल्स होने चाहिए लेंथ इन सेंटीमीटर एंड कम्युलेटिव फ्रीक्वेंसी. सो अगर ये नहीं होंगे तो 1 मार्क कट जाएगा. ठीक है. ओके. नाउ वी हैव टू mark 0, 9.5, 14.5, 19.5 and 30.5 on the x-axis. तो अगर इसको 10 ले लेते हैं, that's 10, that's 20. नहीं, इसको बल्कि 5 लेना पड़ेगा वरना बहुत छोटा स्केल हो जाएगा. So 5, 10, 15, 20, 25 and 30. Okay. Now the first length we need is 0. बल्कि height कहाँ तक जानी है? Height needs to go till 150. So we can take this as 20, 40, 60, 80, 100 and 120. बल्कि 150 तक जानी है. 120, 140, yeah, and 150. So 20, 40, 60, 80, 100, 120, 140 और यहाँ पे 160. Okay, first point is 0, 0. Let's mark that. It's right here. Make a small cross here. Next point is 9.5, 15. So 9.5 के लिए 9 से half box आगे चले जाएंगे और 15 would be 2.5 boxes below 20. इधर. So you have to be very careful with the plotting. कि पता चले आपने 9.5 प्लॉट किया है और 10 नहीं किया प्लॉट या 9 नहीं किया प्लॉट. So here. Next point is 14.5 and 63. So 14.5 के लिए भी 15 से half box पीछे and 63. So 63 के लिए 1.5 box above 60. Somewhere over here. Okay, so that's 14.5 and 60. अच्छा आपने ना यहाँ लिखना भी है कि ये आपका 9.5 है और ये आपका 14.5 है. So we write 9.5 here, 14.5 here. Okay, next is 19.5 and 129. Okay, so this is 20, इसके हाफ बॉक्स पीछे इज 19.5 और इसकी हाइट लेके जानी है 129 तक. So 1 2 3 4 5 6 7 8 right here. 4.5 boxes above the 120 horizontal line. This would be 129. Okay, and then the last point is 30.5 and 150. 30.5 के लिए हम 30 से हाफ बॉक्स पीछे जाएंगे और 150 के लिए हम टॉप से 2.5 boxes नीचे आ जाएंगे. Yes. Okay, now we join all our points.
मैम जो 9.5 एंड 15 वाला पॉइंट है वो 15 थोड़ा इससे भी नीचे नहीं होगा?
9.5 कॉमा 15. देखो पहले 10 है ना, 5 बॉक्सेस पे 10 आ जाएगा. ठीक है, सो 1 2 3 4 5 ये 10 है. अब हमें 15 पे जाना है ना, तो 15 के लिए फिर मुझे इसको 2.5 बॉक्सेस अबव करना पड़ेगा. इस पॉइंट की बात कर रही हूँ ना.
ओह यस.
तो ये टॉप से ना 2.5 बॉक्सेस, मतलब कि 20 की लाइन से इसको 2.5 बॉक्सेस नीचे लाओ. ठीक है,
सही है मैम.
ओके. अब इन सबको एक स्मूथ कर्व से ज्वाइन कर लेते हैं. ऐसे करके कुछ बनेगा. ओके, नेक्स्ट पार्ट में क्या करना है. 40% of these fish have a length of d centimeter or more. Use your graph to find the value of d. Okay, 40% of these fish have a length of d centimeter or more. That means 60% of the fish have length d centimeter or less. अब हम फाइंड करते हैं 60% ऑफ द फिश. ये टोटल फिश थी 150. सो 60% ऑफ 150 होता है 90. सो अब हमने 90 कम्युलेटिव फ्रीक्वेंसी के करस्पॉन्डिंग लेंथ की वैल्यू फाइंड कर लेनी. सो y 90 है तो x क्या है. ठीक है, लेट्स गो बैक टू आवर ग्राफ. 90 is here in between 80 and 100. 5 boxes above. यहाँ डॉटेड लाइन लगेगी. एग्जामिनर को प्रॉपरली अपनी वर्किंग डॉटेड लाइन के थ्रू हम दिखाते हैं. यहाँ पे 90 भी मार्क कर लें और इसके करस्पॉन्डिंग जो x की वैल्यू है वो हम रीड करेंगे. देख के बताओ क्या आ रहा है. फिफ्टीन से आगे आ रहा है. लेट मी चेक मार्किंग स्कीम में क्या लिखा हुआ है. इट सेज अप्रोक्सीमेटली 16.5. ना चेक करके बताएं. Follow through their increasing cumulative frequency graph. Use of graph must be seen. So see, you need to show those dotted lines. If no clear evidence of use of graphs, special case B1 follow through. कह रहे अगर ग्राफ नहीं नजर आ रहा ना यूज हुआ हुआ तो बस फिर 1 मार्क मिलेगा आपको. मेथड का B1 मिलेगा. ओके, सो 16.5 के अराउंड आंसर आना चाहिए. ठीक है, आई थिंक मैंने इसको थोड़ा जल्दी ड्रॉप कर दिया, ये यहाँ से ड्रॉप हो रहा है. सो आई एम ऑल्सो गेटिंग अराउंड 16. Okay, so 16 or 16.5 or something around it. Oops, यहाँ पे था 16.5. Okay. चलिए जी, next part. The mean length of these 150 fish is 15.295. Calculate an estimate for the variance of the length of the fish. अच्छा जी, variance के लिए हमें पहले frequency table चाहिए. ये फ्रीक्वेंसी टेबल ठीक नहीं है, हमें पहले इसको फिक्स करना पड़ेगा ताकि इस पे कॉन्टिन्यूटी करेक्शन लग जाए. ओके, सो आई एम गोइंग टू रीमेक दिस टेबल. 0 तो 0 ही रहेगा, ऑब्वियसली वी कैन नॉट हैव अ नेगेटिव लेंथ. 9 को कर देंगे 9.5, इसी तरह 14.5 एंड सो ऑन. सो लेट्स रीमेक दिस टेबल फर्स्ट विद कॉन्टिन्यूटी करेक्शन अप्लाइड. ठीक है, सो लेंथ in centimeter, then frequency. So length हम लिख लेंगे 0 से 9.5 तक, फिर 9.5 से 14.5 तक, फिर 14.5 से 19.5 तक, फिर 19.5 से 30.5 तक, और इनकी फ्रीक्वेंसीज एज इट इज कॉपी हो जाएंगी. 15, 48, 66, 21. ठीक है, अब मीन तो हमने निकालना नहीं है, मीन निकाल के दिया हुआ है उन्होंने. मीन के लिए हमें वैसे पता है क्या करना होता है. मिड पॉइंट, इनका मिड पॉइंट टाइम फ्रीक्वेंसी प्लस मिड पॉइंट टाइम फ्रीक्वेंसी एंड सो ऑन डिवाइड बाय टोटल फ्रीक्वेंसी. ठीक है, मीन उन्होंने निकाल के दिया हुआ है टू मेक आवर वर्किंग लेस हेक्टिक. हमने निकालना है इसका वेरिएंस. अच्छा, वेरिएंस के लिए क्या करेंगे, इसी तरह इसकी मिड वैल्यू लेंगे, उसका स्क्वायर कर देंगे और 15 से मल्टीप्लाई करेंगे. तो पहले तो हमें इन सब की ना मिड वैल्यूज चाहिए, वो इधर लिख लेते हैं साइड पे. सो 0 और 9.5 को ऐड करके जब डिवाइडेड बाय 2 करेंगे तो 4.75 आएगा. अगले का आएगा 12, अगले का आएगा 17, यू जस्ट ऐड देम एंड डिवाइड बाय 2, और अगले का आएगा 25. ठीक है, सो नाउ वी स्क्वायर दिस. 4.75 स्क्वायर्ड टाइम्स 15 प्लस 12 स्क्वायर्ड टाइम्स 48 plus 17 squared times 66 plus 25 squared times 21 divided by total frequency which is 150 minus mean squared. इसी वजह से उन्होंने ये आपको मीन दिया हुआ है, इसका स्क्वायर सब्ट्रैक्ट कर लेंगे. 15.295 स्क्वायर्ड, और वेरिएंस पूछा है तो हम स्क्वायर रूट नहीं लगाएंगे. अगर स्टैंडर्ड डेविएशन पूछा होता तो यहाँ पे एक पूरे पे एक स्क्वायर रूट भी लग जाता. ठीक है, now you will carefully enter all of this in your calculator and you'll get 29.1 after round. ठीक है, okay, that brings us to the end of the paper. If you have any questions, you'll ask me now.